Okay, so let's take a look at 5.5 trig identities. These are the basic trig identities that you have to memorize. This here, we went over this already, but we can prove these trig identities using first principles. These are something you also have to memorize, that tan is sine over cos. These we went over last section, but tan is the same as sine over cos. That is just something you're going to use from now on. Cotangent then would be the reciprocal of tan, which is cos over sine. And then the most important one after that is sine squared theta plus cos squared theta is equal to 1. Okay, you can go and memorize this one as well, but you can actually get that from the previous. But if you memorize these two, that'll be good enough. Now, if it asks you to prove trig identities, you're going to use these identities in order to prove other things. These are something you have to know. But I will first start off with asking you to prove tan theta is equal to sine theta over cos theta using first principles. Okay, so if I'm using first principles to prove this, what I'm first going to do is break this up into left side, which is tan theta, break up the right side, which is sine theta over cos theta. And then if I'm using first principles, it means using your x, y, and r. That's what first principles mean. And you would only use first principles again if you're asked to prove any of these identities that you are required to memorize. So if I start off with first principles, if I know what tan is equal to, tan is opposite over hypotenuse, but we don't talk about, opposite and adjacent, but we don't talk about opposite and adjacents now, we talk about x, y, and r. Tan is the same as y over x. That's what tan is equal to. On the right side of this, I have sine theta over cos theta. So sine theta divided by cos theta. Now I know sine theta is just y over r, and I know cos theta is just x over r. And if I continue this, if you go to divide, how do you divide two fractions? You multiply by its reciprocal, and its reciprocal would be r over x. Continuing that, y times r is y times r, and r times x is r times x. Then I can divide the r's from both sides, and I get y over x. So therefore, using first principles, the left side and the right side of that equation are the same. So that's using first principles. Again, first principles are used to prove any of these trig ratios that are here at the beginning. Anything else, we are going to use these trig ratios to go prove other things. So for instance, example 1, prove the following identity. So this identity here, you have to prove that tan times cos is equal to sine. The first step is to first break this down into left side. Left side is tan theta cos theta. And the right side. The right side of this equation is just sine theta. Okay, you have to do this or else you don't get any marks. So then you would start with the most complicated side and try to reduce it down to the uncomplicated side, let's say. This side is not that complicated, it's just sine theta. But this side here, I'm going to have to change some things around so that this side looks like sine theta. Now, what I noticed from these ratios that I have up here, I can turn tan into sine over cos. And I'm going to tell the reader that off to the side. I know tan theta is equal to sine over cos. So instead of writing tan there, I'm going to write sine theta over cos theta for tan, and I'll leave this cos theta alone. And that's just like cos theta over 1. This is just a multiplication between fractions, and so sine times cos is sine theta cos theta, and cos times 1 on the bottom is just cos theta. Of course, I can cancel those out, and I'm just left with sine theta. So, of course, the left side and the right side of this equation are equal. Let's take a look at the next ones. The next one here asks us to prove secant times 1 plus cos theta is equal to 1 plus secant theta. So again, I'm going to break this up into the left side. The left side is equal to this, and the right side is 1 plus secant theta. So I'm going to have to somehow change these sides so that they look the same. Now, what looks more complicated to me, I start with the side that looks more complicated. I'll start with this one. And if you can see, this side already has a secant theta, but and so does this side. But this side has a cos, this side does not. This has a 1, this side has a 1. So somehow I got to make this look like that. What I'm going to do first is I'm going to multiply this in. Secant times 1 is secant theta, and secant times cos is cos theta secant theta. So then I'm going to have to, again, try to make it look like this side. This side doesn't look as complicated. This already has a secant, and so does that. This plus is the same as that, but this should probably be a 1. See, if I look at my beginning, I know that secant is the same as writing 1 over cos. So I'm going to use that over here and plug that in. So secant theta plus cos theta. And instead of writing secant theta over here, I'm going to write 1 over cos. Why didn't I switch that one? Because I got to make this side look like that, and this side already has a secant. And so over here I have multiplication between two fractions. So this is secant theta plus, and then cos times 1 is cos, and 1 times cos on the bottom is cos. So this ends up being secant theta plus that divided by that is 1. So I end up with 1 plus secant theta, which is exactly the same as this. Okay, secant theta plus 1, either way. So therefore, the left side is equal to the right side. Let's try another one here. This one here, again, how do I prove? I'm going to break this up into the left side and the right side. So this is the left side right here, divided by tan theta, and the right side I'll leave as sine theta. Now, obviously, I'm not going to begin with this side. It's going to be impossible, virtually impossible, to make this look like that. Now, I can probably do some stuff here to make this look like the more simplistic side. So what I'm going to do is I'm going to rewrite this as secant theta minus cos theta, all of that, divided by tan theta. I'm going to write this instead. And why would I write this? Well, the reason I'm writing it is so that I can start changing things to fractions. So for instance, this secant theta, there's no secants on this side, so I'm probably going to switch that. And secant I know is 1 over cos. So this is going to be 1 over cos theta, and then minus cos theta. And over here, it's going to be divided by. Now, somehow, some way, sine has to make itself in here, way in here. So I'm going to change this tan into sine theta over cos theta, because I know that tan is sine over cos. Continuing this, where do I go from here? Well, I'm probably going to have to come up with a common denominator here between these two things so I can subtract the two things. Now, the common denominator clearly is cos theta. I can switch this to a cos theta by multiplying by cos theta. So I'm going to do the same to the top. Multiply. So cos theta times cos theta on the top is cos squared theta. And then I still have this divided by sine theta over cos theta. Continuing this over here, I'm going to end up with, well, now I can subtract that together, that fraction. Subtract fractions, keep the denominator the same as cos theta, and subtract the top, 1 minus cos squared theta. And then I'm going to have it multiplied by, I'm going to change that to multiplied by cos theta over sine theta, because that's how we divide fractions. Now, the other thing I've noticed is that this 1 minus cos squared theta, I'm going to actually change that. I'm going to leave everything else the exact same, but I've noticed something, and you'll notice this every time you see 1 minus cos theta again. From this identity right here, sine squared plus cos squared equals 1, if I show you this, sine squared theta plus cos squared theta is equal to 1, if I rearranged this over here and brought the sine to the other side, or left the sine here and brought the cos to the other side, I'd get sine squared theta is equal to 1 minus cos squared theta. See, instead of writing 1 minus cos squared theta up here, I'm going to write sine squared theta. Continuing this and doing the multiplication, sine squared plus times cos squared, times cos is just sine squared cos. On the bottom is just cos times sine. And then if I continue this, that divided by that is gone, so I'm left with sine squared theta all over sine. Now remember what sine squared theta just means sine times sine. It actually means this, sine theta times sine theta all over sine theta. So if I cancel out another one, I'm just left with sine theta. So therefore, the left side is equal to the right side because both of them are equal to sine theta. Now people ask me all the time, how do you know what to do? I do not know what to do. I just try to make the simple side, the more complicated side look like the simple side. So this one here, there's a minus sign in the middle there. So just look for part 2 of this lesson plan, and I'm going to do this one here on a separate piece of paper, but it's 1 minus cos squared x equals cos squared x times tan x. So you can try to do this one just before we do it, just before I do it on the next lesson. But just notice this side again, 1 minus cos squared theta. Notice what we changed 1 minus cos squared theta. We used that sine squared plus cos squared equals 1 to change that. So whenever you see these 1 minus cos squared thetas, you can change those things. So you can try that right now, and then stay tuned to my next part.